So what we're doing here is we're building a new device for the Large Hadron Collider. And this device is designed to measure the time of arrival of particles that are created at the LHC with a precision of 30 trillionths of a second. And we're going to use that device to look for dark matter and hopefully observe it and measure its properties. These are the sensitive elements for this new device. What's really important is making these such that the optical coupling between the crystal and the photodetector is uniform and robust, and that the subsequent mechanical specifications of that module are really precise and well made. Student participation at both the graduate student and the undergraduate level, that is the engine for the research that we do at the university.
So every day we make 24 sensor modules and we keep it in the curing box, and the next day we will test all of them. We want to know how good our sensor modules is basically. This is a setup that can test 12 SMs at a time. We try to maintain the temperature of this box always at 23 degrees Celsius, and that is why this big chiller here, and we call it Poly.
Why does it have the name Poly?
It's actually the company of this chiller is Poly Science, and one of the undergrad decided to call it, made it short basically.
Poly, very good.
After testing the sensor modules there in the other room, we bring it here, we pair it. We pair it on the basis of closer light yields and the categories. So what we do is we pair in a way such that every pair has at least one A category sensor module. We bring it here after pairing to make a detector module.
So now we're going to focus on the thermal efficacy of the detector module. So we're actually going to come over here. So this is a cold plate. And so its job is to take the heat away from the electronics in the detector module as it functions. And so what we're measuring is the temperature difference from when we start the test to when it ends. And so we're looking for the four corners of the detector module to be just about the same. They don't need to be perfect, but that's the idea.
This is our precision timing layer clean room here at UVA. We've got 2 graduate students and 2 undergraduate students in here right now. We call these trays.
As you can see, there are many of electronic components. So what we want to make sure is that all these components can communicate with each other. We can read the temperature and current from the whole tray.
A tray successfully goes through that battery of tests. We say this tray is now fully compliant. It meets all of our specifications. It stays in its cradle, it goes into a shipping box, and it will eventually be shipped to CERN. We expect to send our first box of qualified trays to CERN in the next few weeks. And that's going to be an exciting moment.